In this tutorial, we will focus on how to create frequency tables. To be a bit more specific, we will cover how to calculate the class intervals, class limits, class boundaries, the midpoints for a class interval, frequency, relative frequency, percentage frequency, and finally the cumulative percentage frequency. For this tutorial, we will use the data in Table 2.5 of the textbook. Table 2.6 provides you with the completed frequency table for this data. This will be the frequency table that we will recreate here. I've taken the 20 numbers from Table 2.5 and just arranged them in numerical order. It's not completely necessary to do, but it does make it easier for us to calculate the frequency numbers later. So from this point on, just remember that these numbers came from Table 2.5 of the textbook. As you can see, we have a blank frequency table with the same 8 columns in the frequency table from Table 2.6. We will fill in this table one column at a time as we go through the different steps. The first thing we'll work on is how to calculate class intervals. Remember that the definition of a class interval is a set of values that are combined into a single group for our frequency table. To calculate a class interval, we have to know the range of the data, the desired width for our class intervals, and the number of class intervals. So to start, we first calculate the range of the data. To do that, we just subtract our lowest number from our highest number. In this case, we have 73 minus 42, which equals 31. So the range of our data is 31. Now, to determine the width of our class intervals, we need to first know how many intervals we want. In our example here, we want 4 class intervals. So the width will be our range divided by the total number of intervals that we wish to have. So we divide 31 by 4 to arrive at 7.75, which will round up to 8. Starting at our lowest number, we then get 42 to 49 for our first class interval, 50 to 57 for our second class interval, 58 to 65 for our third class interval, and 66 to 73 for our fourth class interval. Now often, people forget to count the first number in the class interval. For example, adding 8 to 42 to make the first interval 42 to 50 rather than 42 to 49, and so on with the remaining intervals. Let's take a quick detour here to see why we need to count the first number in the class interval. Now picture all of the numbers in our data falling along this number line. We have just created 4 equal intervals with the width of 8 in order to capture all of those numbers. So our first interval must include the number 42 in those 8 numbers. So again, we have 42 to 49 for the first interval, 50 to 57 for the second interval, 58 to 65 for the third interval, and 66 to 73 for the fourth interval. Now we have just completed what is likely the hardest part of creating frequency tables. Now that we have our class intervals, we can enter them in our table. The next thing we need to do is calculate the class limits. Class limits are the values in the data that are used as the starting and ending values for each interval. Simply put, they are the first and last numbers in each interval. So we have 42 and 49 for the first class interval, 50 and 57 for the second class interval, 58 and 65 for the third class interval, and 66 and 73 for our fourth class interval. Now that we know our class limits, we can enter those in our table. Next, we have class boundaries. Class boundaries are numbers that may not necessarily exist in the data, but define where the cutoffs are for each class interval. For example, where would we put the number 41.8 or 49.3? You can see that these fall outside of our first class interval. So we need class boundaries to tell us where to put the numbers that fall in between our class limits. One way to remember how to calculate these is to subtract 0.5 from the lower limit and add 0.5 to the upper limit for each class interval. So for our first class, our class boundary will be 41.5 to less than 49.5. Now you'll notice that we have the less than sign in here. This means that a number like 49.4999 would go in the first class interval, but a number such as 49.50001 would go in the second class interval, where its boundary is 49.5 to less than 57.5. For the third class boundary, we have 57.5 to less than 65.5, and finally for the fourth class boundary, we have 65.5 to less than 73.5. Now that we have our class boundaries, we can enter those in our table. Next, we have the midpoints for each class interval. The midpoint is the average value of the class interval. Sometimes you'll find that it is used as a rough estimate of the average case within an interval. To calculate the midpoints, we add the lower class limit to the upper class limit and divide that result by 2. So for the first class interval, we get 45.5. For the second class interval, we get 53.5. For the third class interval, we get 61.5. And finally, for the fourth class interval, we get 69.5. Now that that is done, we can enter our midpoint values for each class interval. Now the rest of the table deals with various forms of frequency. Frequency refers to the number of observations that fall into a given class interval. Remember, we need to keep our class boundaries in mind to determine where to place the numbers. In this example, we don't have any values that fall outside of the intervals, so we can just go ahead and count the number of values within each class interval. For the first class interval, we have 4 numbers, so the frequency for the first class is 4. For the second class interval, the frequency is 5. For the third class interval, the frequency is also 5. And for the fourth class interval, the frequency is 6. So now we place our frequency values in the frequency table and add them up to obtain the total. This is a good spot to just check to make sure we have accounted for all of the numbers in our data. The total frequency is equal to the total sample size of the data. We know that there are 20 numbers in our data, and we can see that we have a total frequency of 20, so it would appear that we have accounted for all of the values. Our next task is to calculate the relative frequency. The relative frequency for a given class interval is the proportion of the total number of values in the data that are in that particular class. So since there are 20 values, the relative frequency for each class will be that class's frequency divided by 20. So for the first class interval, we have 4 divided by 20, which is 0.20. For the second class interval, we have 5 divided by 20, which is 0.25. For the third class interval, we have 5 divided by 20, which is 0.25. And for the fourth class interval, we have 6 divided by 20, which is 0.30. Finally, we add these proportions together to get the total relative frequency. We should arrive at a value of 1 here, since we are dividing the frequencies by the total of 20. Now on to percentage frequency. If you already have the values for relative frequency, then the easiest way to calculate percentage frequency is just to multiply the relative frequency by 100. If you haven't already calculated the relative frequency, then to calculate percentage frequency, you just follow the procedure for relative frequency and multiply by 100. So for the first class interval, our percentage frequency is 20%. For the second class interval, it's 25%. For the third class interval, it's 25%. And for the fourth class interval, our percentage frequency is 30%. Again, we add up the percentage frequency, and if we did our calculations correctly, we should end up with a total percentage frequency of 100%. And now for the final column in our frequency table, the cumulative percentage frequency. The cumulative percentage frequency gives the percentage of observations up to the end of the class interval. So all we're doing here is taking a running total of all percentage frequencies. For the first class interval, the cumulative percentage frequency will be 20% because we do not have any class intervals before this one. For the second class interval, we add the percentage frequency for that class interval to the cumulative percentage frequency for the last class interval to get 45%. We now just repeat that process until we're done. So for the third class interval, the cumulative percentage frequency is 70%, and for the fourth class interval, it's 100%. And that brings us to the end of our statistics video tutorial for Chapter 2. We hope that you have found this tutorial to be useful. If you haven't already done so, you may want to try the two interactive figures for this chapter. The first illustrates the probability of matching birthdays from Figure 2.9, while the second provides a demonstration of the box plots in Figure 2.22.